Hello. Today we're going to start our lesson by looking at the compound interest formula. And you can see I have the function written there. A of t equals p times the quantity 1 plus r over n close quantity to the nt power. So this gives the amount of money in a bank account. T is going to represent years. R is going to be the interest rate in a decimal. Compounded n times per year. So let's take a very easy example of this, and we're going to start compounding it more and more often, and we're going to see how the money in our bank account changes. So we're going to start with $1, and we're going to do 100% interest on this $1. And we want to see how much is going to be left after 1 year. So what this tells me is that my principal is going to be $1. The interest rate is going to be, it's 100%, but if we turn it into a decimal, that's just the same as moving it over 2 decimal places to get just 1. And my time is going to be also 1 year. So when I fill all this in, annually, we're going to compound it so that n is going to be just 1. So when I fill this in, so a sub 1, that means the amount of money 1 year later is $1 times 1 plus r is 1 over n, which is 1, to the n times t, so that is 1 times 1. So to simplify this up a little bit, we get 1 multiplied by 1 plus 1 to the first power, or rather it's 1 times 2 to the first. 2 to the first is 2 times 1 is 2. So we would have $2 in our bank account if we got a 100% interest compounding annually on our money. Okay, so how about biannually? So we're going to compound a little bit more often here. So our n now biannually is going to compound twice in a year. So what do we come up with here? Well, we're still looking after 1 year, so we have a sub 1 equals, and we have 1 times 1 plus 1 half now, because n is now 2, to the 1 times 2. So we're compounding twice, and we're doing it at a different rate. So 1 times 1 plus a half is 1.5 to the second power. So notice that we're multiplying our money by a smaller number, but we're multiplying it twice in there. So see how this changes. And really we're just doing 1.5 squared, which gets me 2.25. So even though you're not getting a full 100% interest each time you compound, just by doing it twice instead of once, then you get an extra quarter. Okay, so let's increase it again. So we're doing it quarterly, so that means my n is now 4. So we're still looking at, after 1 year, my principal is still 1, so 1 times 1 plus, and we have the rate is still 1, but we're doing it over 4 now, times 4 times, to the 4 times 1 equals, and we simplify this up, 1 plus a fourth is 1.25, all to the 4th power. And again, you can see we're multiplying a smaller number, it's 1.25, but we're going to do it 4 times. So what are we going to get? Well, 1.25 to the 4th power is 2.44, so $2.44. So again, our amount at the end is going to be slightly higher. So the more often we compound our interest, the more money we're going to make. So what's it going to look like if we compound continuously? Meaning at every single moment we continue to compound our interest here. So let's take a look. You can see on this slide I've given you a spreadsheet here, and what we do is we continue to change the amount of times that we compound our money. And going from top to bottom, we start to compound more and more often. And what you notice is, as you start to compound more and more often, our numbers start to get closer and closer to this number right here. And this number is referred to as E. E is a constant in mathematics, and it is something that we use for continuous compounding interest. Okay, so as n gets larger, that means the number of times we compound, the money in the account will start to approach E using our model of a $1 bank account at 100% interest. Okay, so we have A of t equals P to the ERT down here, and this is a formula that we can use for compounding interest. So you are going to need to bring that to class and be prepared to use it. Another thing worth knowing is basically the constant E, and we're going to be seeing that multiple times this year. It's not going away after we leave continuous compounding interest. Y equals e to the x power is referred to as the exponential function, as opposed to an exponential function. This one is the exponential function. It's got its very own unique concepts. And so we will be talking more about that as this year goes on, so please get used to that now. And we are done.